Hi, in this last example of the lesson, we're going to go ahead and look and see how we would apply this to a real life scenario. Um, we have a table here showing the number of cell phones sold in March and in August. And what we're going to do is we're going to use our equation that says that the number at a particular time is equal to your original value times e to the kt power. And the reason we're using that is because it tells us that these rates are increasing exponentially. And we also want to find this rate, which is going to be our k constant. And to solve for that k constant, we're going to have to use some of the techniques we've been learning earlier this lesson. So let's go ahead and put in our number at the time of 5 months. So if our original month was March, August would be 5 months later. So our time currently, as far as we know, is August, where we sold 177 phones. And our original value, as far as we know, is March, which sold 88. And we're going to take that e to the k times 5 months power. So now we're going to go ahead and solve to get this k by itself. We're going to get e by itself first. So let's divide both sides by 88. And we get 177 88 equals e to the 5k power, essentially. And to get that 5k down from the exponent, what we can do is we can take the ln of both sides, since ln and e essentially cross out. We're going to have ln of 177 over 88 equals 5k. And let's figure out what the ln of 177 over 88 would be. (177 over 88) would be 0.70 essentially. So we'll say 0.7 equals 5k. Then we divide both sides by 5. And we get k is equal to 0.7 divided by 5, about 0.14. Now your rounding could change that a little bit, but what that does for us is it allows us to write an equation that n of t, given that time is in months, is equal to 88 times e to the 0.14 t power. And that will tell you, no matter how many months you give it since March, for t, you can find out how many cell phones were sold at that particular time. Now, what we can also do with the techniques we've learned this lesson is solve backwards for the amount of time it would take to reach 500. So in this case, our rate is what we found earlier, and our n of t is going to be 500, the number of phones we're looking for. So let's set this up as 500 equals 88 e to the 0.14 times t. Now notice our what we have to solve for, our unknown is in the exponent. So let's first get that e by itself, divide both sides by 88. So we have 500 divided by 88. We get 5.68 equals e to the 0.14 t power. Let's take the ln of both sides. The ln and the e essentially cross out, and we get ln of 0.568, which is, I could just say, let me be exact and say ln of the answer we got is 1.74 is equal to 0.14 t And then I can divide that number by 0.14, and I get 12.4 for my time. So after about 12 months or a little over a year is how long it would take to sell 500 phones in a month. So now you're given this information in the table between May and July. Go ahead and see if you can figure out the rate of growth for this situation.